Great. I welcome you once again to today's lesson. We are still on the questions of the 2025 Wassce, and this is the question 4 of the elective mathematics. So, in this question, we are given this rational function to resolve into partial fraction. So, when we say resolving such a fraction into partial fraction, what do you mean by that? So, this is just a matter of what finding the sum of the various components of the given fraction. Okay, yes. So it means what will be the component of this, what will be the component fractions of this given rational function. That is what we mean by what resolving. So when you are able to find them, then as you are summing them up, then we are saying you are resolving what this particular um, fraction into partial fraction. So looking at this one, we are going to apply this principle to be able to resolve this fraction. So looking at what we have here, this is in the form of what is given in the question. So once you have this, all that you need to do is that because we have a cubic function as our denominator, we need to factor um, x out so that we'll be able to um, get what we are going to do. Okay, so if you try to factor x out, this is what we are going to do. Get. And why are we saying we have to factor x out? Yes, so one thing you should know is that before you be able to solve partial fraction, you have to ensure that the the rational function given to you is what is a proper fraction. Is a proper fraction. So what do you mean by proper fraction? So when we say proper fraction, as we all know that a proper fraction, that is when the numerator is less than the denominator. In this case, this is what expressions given. So we have the expression at the numerator and expression and the denominator, which in all is what a partial a rational function. So in this case, when you realize that the degree of the numerator is less than the degree of the denominator, then you can say that is what a proper fraction. Okay, yes. So before you be able to resolve any um, rational function into a partial fraction, you have to ensure that it is what a proper fraction. Okay, whenever you are given a question which is not a proper fraction, then you have to divide the numerator by the denominator. Then you can um, resolve into partial fraction. And how when are you going to say that this is improper fraction? This is not a proper fraction. That is when you realize that the degree of the numerator is either equal to or greater than the degree of the denominator. Once you realize that, then it is improper, and for that matter, you need to um, divide it the numerator by the denominator to be able to get a proper fraction before you can resolve. By looking at this question, it is already what proper fraction, so we can solve it easily. Okay, but you should also note that there are times that you may be given a question where the denominator is a linear form. You may also be given when the denominator has what repeated linear form, or when the denominator is a quadratic form. When you realize that you have this, then we have various ways of solving for such examples. In this case, our denominator is a cubic what expression or function. So what do? We need to factor x out so that we get one linear, we get one quadratic as you have it here. And once you are able to do that, then you can resolve it as this a on what x. So it means the x takes the linear part, and then we have the quadratic part, which also what is resolved by x bx plus c, all divided by the quadratic part. So based on this, we are going to look at how we can solve this question. Okay, yes. So whenever you have such an example, please, this is how you can go about. All right, if that's the case, then let's try and see how best we can solve this. Solve this question. Okay, so this is what we have. Okay, so as I said, all that we need to do is to factor one of the x's out, because we have a cubic function like this in this form. I'm saying when you have it only in this form, there are times that you may get different questions, and we also have different ways of doing that. But in this particular question, this is how you are supposed to do it. So if you are to factor x out, then this is what we are going to have. We have x multiplying x squared plus x minus 11. Okay, once you're able to factor out, then you apply that principle given initially. Okay, so the x you have there, that is the linear part, and then the x squared plus x minus 11 also got a quadratic part, and this is how we can resolve it. Okay, so you see this, so this is the fractional component of the rational function given. Okay, so we are going to find the values of what a, b, and c. Then when we are done, we substitute our values. Okay, and that gives us what the resolution of this particular rational function. Okay, all right, if that's the case, then we can proceed. So if you have this, how do you um, work out? Because this is fraction, you find the LCM, multiply through by them. So right now we maintain the left side and work with the right side. So if that's the case, then it's just a matter of what? Multiplying the a by x squared plus x minus 11 plus b multi x plus c multiplying what? X. Okay, all divided by the LCM. Okay, so once you realize that this is what you have, then the rest of the question is very, very hot, easy. Okay, so what you do is that we only what find the identities. Okay, and in finding the identity, that's where we equate the left hand side to the numerator of the left hand side to the numerator of the right hand side. Okay, yes, so that is what we are going to do right now. Okay, if that's the case, then we are going to have as what 2x squared plus 7x plus 33 is equal to a multiplying the expression x squared plus x minus 11 plus bx plus c, all multiplying what? X. Now once you have this, there are two ways that we can find the values of a, b, and c. Is either we use the cover up method, and in using the cover up method, that is where we decide to choose a value for x. When we substitute the value, any of the terms, especially at the right side, will go zero, so that we'll be able to find any of the unknown variables. Okay, it's either maybe bx plus c multiplying x will go zero, then we get a leaving alone, so that we find a, or a side will go zero, and then the b and c will be left behind, then we find one of them. So if I'm using the cover up, then if I choose x to be zero and I substitute, you realize that bx plus c will go zero. Okay, then I'll have my a there. Okay, if that's the case, then when x is 0, then we can substitute the zeros and get that. And if we substitute 0 at the left side, you realize that 2 multiplying 0 squared plus 7 times 0 gives us 0 plus 33. And at the left side, the b plus c side will be 0, where we have what? So we are going to, at the end of the day, we are going to have 33, which is equal to negative what? 11a, negative 11a. And if you find a, what are we going to get? We are going to get, that's when we divide both sides by negative 11, and then our a gives us what? Negative 3. So we are able to find a. Then we ask ourselves, can we still use the cover up? Once we're able to find a, can we still choose another number? This time we choose x to be 0. Can we choose a different number? We can't use 0 because we already used that. Okay, can we choose 1? Once you realize that we can't choose any number again, then we can also employ the use of what we call undetermined coefficient. Undetermined coefficient. Okay, yes, so we are going to use the undetermined coefficient. Yes, so for the undetermined coefficient, that is when we try to expand the bracket. Okay, then we group items. After that, we compare the coefficient of the left hand side to the right hand side, and then we so that we're able to what? Find the values of B and C. Okay, yes. So in this case, we have already calculated for A, which is -3. So we just substitute that and then open the bracket. Okay, so once we have that, then we multiply 3 by the expression x squared plus x minus 11, and also multiply x by the expression b x plus c. Okay, as for the left side, we keep it. Okay, we maintain it. So if that's the case, then we are going to have um, this as our answer. That is 2x squared plus 7x plus 33, which gives us what? -3x squared minus 3x plus 3 plus bx squared plus cx. So once we have this, then we can quickly what? Group like terms. Okay, so if you are grouping like terms, then we can put -3x squared and bx squared. We keep the left, as I said, we keep because we are using method of what? Undetermined coefficient. That means we work out for the left right hand side, then after that we compare to the right side, we pick the corresponding what? Coefficients. Okay, and then work out. So if you group like terms, then we have 3 at the right side, we have -3x squared and what? Bx squared, and then we also have -3x and the cx, and then we have the constant. Okay, once we do that, then for the -3x squared and bx squared, you can factor x squared out, and for the -3x and the cx2, we can factor x out. If that's the case, then we can have it as this. Yes. So once you realize that we have this, so you can see that if you look at the left side, we have 2x squared. If you look at the right side, we have what? B minus 3 multiplying what? X squared. So they are corresponding. Okay, they are the right side corresponds to the left side. Then we can pick B minus 3 to be equal to 2. If you look at the 7x at the left side and look at C minus 3 multiplying what? X, they also what? Correspond. Then we can also equate 7 to C minus 3. And if you look at the constant values, that is the 33, see that is the same. If that's the case, then we can have our 2, which is equal to B minus C, and then 7, which is equal to C minus 3. Okay, so once we have 2 equal to B minus 3, then we can proceed and solve for B. Okay, in that case, we group like terms by so if we are grouping like terms, then we can have what? 2 plus 3, which is equal to B, and therefore our B gives us what? 5. Okay, yes, once we have B, then we can also find C. So 7 equal to C minus 3, we can group like terms, which will give us what? 7 plus 3, which is equal to C. Okay, and therefore our C is giving us what? 10. Okay, so once we are able to solve for B, C, and A, where we know that the A is giving us a -3, then it becomes easy. We are done. So all that we do is we just substitute these values to the general equation, which is giving us this. So we are only going to put -3 in place of what? A, we put 5 in place of B, and then we put 10 in place of what? C, and that resolves everything. Okay, so once we have this, then we can just do the substitution quickly, and that gives us what? -3 on x plus 5x plus 10 dividing what? Divided by x squared plus x minus 11, and that resolves everything. Okay, so when we say resolve it, you see that we have the component fraction of such fraction, and that answers everything. Okay, that is the end of today's lesson. So my dear student, I encourage you to solve more questions. Okay, all right, so we shall end here and continue next time. My name is Evans, and this is Wassce TV. Kindly subscribe to our YouTube channel. You can also search Wassce TV on TikTok. Kindly follow for more updates. See you next time.